Okay, class, the next factoring pattern we're going to look at is factoring using a quadratic pattern. So sometimes we get something that could be a quartic or it could be to a sixth degree, but it's in a pattern that is quadratic. So let me show you what I mean. Let's start by multiplying this out. So make sure you write all this down, of course. So when I multiply this binomial by this binomial, look at what happens. I get x to the fourth plus 2x squared plus 5x squared plus 10. And what I get is x to the fourth plus 7x squared plus 10. And notice that this is sort of in a quadratic pattern in that it's a trinomial. The degree here is the same as is twice, my bad, twice the degree here, and the degree of this is 0, right? This would be x to the 0 power. And also notice that when we multiply it out, these two terms in the middle have the same, so they end up adding together. Well, we can use that kind of pattern with some other things we could be given. Now, let's look at this. This is a good old regular quadratic. And the way that it's going to factor is going to be x plus 2 times x plus 10, right? 2 times 10 makes 20, 2 plus 10 makes 12. Voila, we like it. It's good. But could we do something that's sort of similar? What if we had x to the fourth plus 12x squared plus 20? Could we use this same idea? Yes, we can. What multiplies to make x to the fourth? Well, that's going to be x squared and x squared. What multiplies to make 20? Well, that's going to be 2 and 10. And let's just check, multiply it back out to make sure that we've got this concept. X to the fourth plus 10x squared plus 2x squared plus 20. Our middle terms are going to add together to make 12x squared. So we get x to the fourth plus 12x squared plus 20, and it works. But what if instead of 4 and 2, this was instead 6 and 3? How would that change things? Well, our numerals are all going to be the same, but what happens to the degree of our variables? Well, so we'd have to have x cubed and x cubed. And when we multiply that, we would get x to the sixth and 10x cubed and 2x cubed, and that would give me x to the sixth and 12x cubed. Notice that 6 is twice 3. Well, I mean, I don't know. Would it work with, I do know actually. Would it work with, say, something like to the 10th and the 5th? Yeah. X to the 5th times x to the 5th, x to the 10th, 10x to the 5th, 2x to the 5th. And so I hope we start seeing a pattern here. Let's try another problem. Let's see if we have this one. I want you guys to write this down, pause the video, try and solve it, or I should say factor it, you're not solving, and come back when you have an answer. Okay, we're back. Did you get x cubed minus 7x? I'm sorry, minus 7 times x cubed plus 3? I hope so. That's correct. Multiply it back out just to check. X to the 6th plus 3x cubed minus 7x cubed minus 21. Adds to make negative 4. I like it. We're good. Check. Now, there is something else that we can do. It's my favorite thing. You can tell in my voice I'm excited and I feel, a little sinister sounding perhaps. We've got 8. We've got 4. 8 is twice 4. We have, x to the 0 right here. We can't even see it because it's invisible because any number to the 0 power is 1. So let's check this out. We're going to get x to the fourth. Now, what multiplies to make negative 32 and adds to make negative 14? How about negative 16 and negative 2? Do you guys agree with that? Oh, but here's why I was so sinister. Do you guys see x to the fourth minus 16 is a difference of two squares? Well, let me just factor that real quick. X to the fourth minus 2 is not a difference of two squares because 2 is not a square. But when I factor this, I'm going to get x squared plus 4 and x squared minus 4. Oh, no. You didn't. I did. X squared minus 4? That is also a difference of two squares, which means I can factor that further. But I need to make sure I bring down my other factors like x to the fourth minus 2, which is not a difference of two squares because 2 is not a square, and x squared plus 4, which is not a difference of two squares because it's positive. We're adding, it's not subtracting. So now that leaves this one, x plus 2 times x minus 2. Don't mind if I do. And this, my dear students, is the answer, fully factored. Woohoo! So, to summarize, factoring using a quadratic pattern, we get things that are not quadratics. They might be quartics. They might be to the 10th degree. They might be to the 6th degree. But we can use what we know about factoring quadratics to factor them, and then know that I love to put in a little difference of two squares whenever I can. So keep factoring. Factor completely.